Okay, this is a little video to go over my breakdown of an AC system and the cycle and how refrigerant moves through the cycle and what you should be able to see in the different areas of that cycle. All right, so we're going to start with a TXV, my compressor, condenser, receiver dryer, TXV, and evaporator. Okay, first thing we're going to do is divide this into quadrants. All right, and we're going to split it through there. All right. So in this quadrant, we're going to look at, our refrigerant is moving clockwise. Coming out of the condenser, we are going to have refrigerant moving over into my condenser, coming out of the condenser into the receiver dryer, and then out of the receiver dryer into the TXV. All right. From the TXV, we're going to come out of there and into the evaporator. Out of the evaporator, I'm back into the compressor. All right. So the way that I describe this is everything to the right side of this vertical line is going to be high pressure. Everything to the left side of this is going to be low pressure. All right. On the bottom side of this horizontal line, everything should be in a liquid. All right. So, and everything above the horizontal line will be a gas. So that is the basic of it, right? And if you look at this, then you could look at this side, it would be a low pressure gas, high pressure liquid, low pressure liquid. All right. So what my refrigerant does as it moves through the cycle is the compressor takes the gas coming into it, and we'll talk about that when we get here, takes the gas that's coming into it and it pressurizes it. What we need to do is raise the pressure and therefore the temperature to get it coming into my condenser. Now it's a high pressure gas. What happens to the gas as it passes through the condenser is that it condenses a little bit because the air moving over here takes the heat and removes that heat back out to the atmosphere. As it moves through this, as that gas condenses, that's why we end up with a high pressure liquid coming out of that and into the receiver dryer. The receiver dryer is going to filter and dry. There's a desiccant in here, and we're going to dry the refrigerant. If there's any moisture, and I mean water in the system, it will be held in the receiver dryer desiccant. Comes out of the receiver dryer and into the TXV. Now the receiver dryer acts as a little bit of a storage unit as well, so it will hold a small amount of refrigerant in there and provide the volume we need for the system. The refrigerant passes through the TXV, and in here we have a restriction, and when we have flow going through there, we create a pressure drop. The pressure drops and the refrigerant will start at that point to start to evaporate in the evaporator. So we're going to have liquid moving through here, and as it uses some of the heat that's coming in from my my blower fan over the evaporator core, what we're going to have then is that heat will be absorbed into the refrigerant and move up into my compressor, and what we are left with then is cool air or lack of heat air coming into my cab. At the compressor, right, and again, remember now we've evaporated the liquid refrigerant and we are in a gas state, and what we are going to do then even though this line feels cold, it actually has absorbed the heat from this air. So there is some heat in there. And when then coming back to our cycle again, the compressor takes that small amount of heat and raises it, or compresses it and raises the temperature so that we can complete the cycle and everything should work. All right. It is a continuous loop. So we're always condensing the gas into a liquid, and then we're evaporating the liquid into a gas, and it is a continuous cycle. That is a TXV, and where the components should be located in there. Okay, now without changing too much of what we just covered, what we have done now, we have switched to an orifice tube system. So instead of my TXV as an expansion device, I have an orifice tube. And instead of having a receiver dryer down in this quadrant, I now have an accumulator in this area. So we go from a high pressure liquid to a low pressure gas. All right. All of the heat exchange, all of that still works the same. The only difference is that my accumulator now is set up so that it has a desiccant in here, and it will do any removing of moisture or water from the system here. And, you know, and it acts again as a little bit of a storage reservoir. There is one of the reasons why we have the accumulator here is a safety device in essence for the compressor. Because the orifice here is fixed, if my compressor continues to run and we don't have the right amount of heat exchange over my two heat exchangers, then what will happen is I may end up with a case where some liquid may work through and into here. It will drop into the bottom of the accumulator, and it will use the heat from around the engine compartment to finish converting that from a liquid into a gas and then moving it into the compressor. And that is to prevent liquid refrigerant from going to the compressor, because we cannot compress a liquid. All right, and that should be a kind of a basic breakdown of the two systems. All right. Without including the receiver dryer and from the TXV or the accumulator from the orifice tube, if you just have these four components, you should be able to still go through and identify then on a system what the refrigerant is in that component or in that line as you are moving through the system. All right. You can use pressure checks to kind of to monitor everything, but just simply looking at this, as my refrigerant moves through there should be small temperature changes as we go through. On this side, right, like coming out of the compressor, it will be very hot, and coming out of the condenser, it's still going to be very hot, but it's going to be cooler at this point than it will be at this point, and it kind of checks the operation of the system. Same as in here. As soon as we go through the orifice tube, that line might be a little cold, but when we get through the evaporator, it should be completely evaporated and very cold coming out of the evaporator.